Hi Ellis, Mr. Grandpa Craig. I wanted to show you how to do something on this meter right here. So this is a small electrical test meter that does voltage, amps, and resistance, stuff that I'll have to explain to you later. But I wanted to show you how I'm going to change a fuse in the back of it, and I want to talk to you about batteries. So this little guy right here is the battery. The whole idea behind the battery is that the battery puts out a little bit of electricity. So the battery, runs the machine, the same as like in this thing right here, which is like a TV remote or a cable TV remote. That has a battery in it too. So the battery's in the back. Right here, you take this thing off, and sure enough, there's a couple batteries right there. So that's how the thing is powered. That's where it gets its power and its electricity. So these little tiny handheld devices like this is another meter. These little tiny handheld devices run off of batteries because they don't require a whole lot of power in order to do what they want to do. Another thing that we're going to look at here is called a fuse. So this is a fuse. You can't tell, but inside of there is a little tiny wire, little teeny tiny wire. Okay, so this stuff in the center here is glass, and inside of that glass is a wire that connects these two pieces of metal together. Okay, so what happens is the electricity comes here, and it can actually go across that little tiny wire to the other side and make a connection. And when you have an electrical circuit, the electricity goes in a wire like this. So here you have a wire, and if this wire, okay, this is all one wire, okay? So if you have a wire and you can make a circle like that, electricity will flow all the way around in the circle, okay? It'll go all the way around and follow through that wire. Maybe it'd be easier to see the red one. So I'm gonna cut it off just for instance. Okay, so let's see here. Here's your circuit, right? So you got metal is connected to the wire on the inside, and it goes around, and that's how electricity flows. It goes through the wire like that. Okay, so if we're saying that, for instance, this was connected to a wire, this metal on the fuse is connected to a wire, and went around and came back around, or wherever it went, and then connects over here on the other side. So that's a circuit when you have a whole circle and you have other stuff in there. Okay, so you have something here that it connects to here, and you have maybe something over here that it connects to over here, and as it goes from point to point, it could be a switch, it could be a light, it could be a button, it could be whatever, and as the electricity travels around and goes from place to place, it makes connections at each point. So the fuse connects to these two spots right here, right here, and right here. And the idea behind a fuse is that it's designed to be very fragile in case something goes wrong with the circuit. If there's too much electricity going through the circuit, then this very fragile tiny little wire that's inside of there actually breaks. And it's designed to do that. It does that on purpose. So it protects all the rest of the circuits and all the other wires and the buzzer and the light and the meter and whatever is in the circuit is protected because this little wire that's designed to be weak actually breaks. So that's a fuse, and I hope that sort of explains how a fuse works. So you see on the back of this is a printed circuit board. So this is a coil, this is a potentiometer. Here's some wires that are going various places. And these are all separate circuits, okay? Now the battery connects to a piece of steel here and a piece of steel here, and we can just kind of imagine how the electricity might go. So if this is the negative or the cold side of the battery, it creates electricity inside of the battery by chemistry. So there's kind of a chemical reaction that happens inside of there that creates electricity. So electricity comes out this metal wire here. See how it goes here, and it goes into the board, and it goes underneath the board, and there's all kinds of wires and stuff on the back side of the board also. Well, let's just imagine that it goes to this black wire right here, then it comes over, goes down, goes to this, which is the meter, comes out of the meter, goes down, goes around through this little diode right here, comes out, goes to this orange wire, goes into the back, comes out, goes to this resistor, then this resistor, then this resistor, and then maybe to the fuse, across the fuse, down on the cold side of the fuse, back to this white wire, loops back around, goes here, and then eventually shows back up over here. So as I'm saying, it creates a whole circle. Eventually it comes all the way full circle, and it goes all the way around. And that is a closed circuit. When it's all closed and it's working, electricity flows all the way around. When there's a break in the circuit, like if the fuse breaks or if a wire becomes disconnected, that circuit becomes what they call open, because there's an opening in the circuit, and it ceases to function if it's a series circuit. A series circuit means everything has to go in a series one after another. There are different kinds of circuits that are not series, but that's the gist of that. So that's how it sits. It just sits in that little holder right there, and you can take it out, and when it breaks, you take it out and you put another one in case you're accidentally probing something that doesn't go the right way. It trips the fuse to protect the whole device. So otherwise, instead of breaking this whole thing because the electricity went in there the wrong way, it just blows that fuse. The fuse is a protection to keep from blowing up the whole device. Most all these devices come apart with a little tiny screw in the back, maybe 2 or 3 of them. I'm not recommending that you start taking things apart just yet, and please don't take apart anything that doesn't belong to you. Never take apart your mother's TV remote or DVD player or any of that stuff. Don't take apart anything that doesn't belong to you, because it's not yours to mess with. But if someone gives you an old can opener or an old radio or something, feel free to take it apart. These are 3 screws right here to take the back off of this device. This particular panel right here is where the batteries are inside of there. This is a more expensive and a fancier test instrument. It does different things, and it has a digital readout. Okay, that's a digital readout. Meaning it shows you those kind of numbers like that. This is an analog readout. This is old school stuff. Analog is still around. Analog is an underlying technology under a lot of the digital stuff that you see. In other words, we think of everything these days as being digital, but in fact when you're using like your cell phone, or when you're using any wireless instrument, that wireless technology still operates on analog signals, which is the way the radio frequencies go through the airwaves. It's the way wireless works. So this is an analog device, and there are situations in testing where you need an analog device. Several years ago, there was a certain kind of car that lets you check the check engine code on the car by using a meter like this, but it had to be an analog meter like this so that it could do a sweep. I'm going to show you how a sweep works if I can get this thing set up to where it looks like you can see it. Let me take a look here. Okay, so I'm going to try to show you a sweep. Maybe I can get this meter to move, or where you can actually see it. Now we're going to watch for this red needle to move. There's a red needle right here, inside there. See if you can see it move. And it didn't move, I got to turn it on. Okay, so I've turned it to ohms because I'm measuring resistance. And there you see it moves. See? Okay, so what's happening there is I'm measuring resistance. Now you remember on the other video I showed you, I was telling you on an electrical outlet, that there are those gaps, right? On an electrical outlet. Hang on. Well, here, so on that electrical outlet, I was telling you before that electricity doesn't go across there. That's an open, okay? That's an open place in a circuit where electricity cannot go across. So when you put something into the circuit like that, that would close it and create a circuit, except that this is also open. This is where the battery goes for the battery charger, so it's still open. But here's my point. So you have these two test leads, okay, and these are metal. So these two leads are these two leads right here that go into the, this is the red one and this is the black one, and they go into the meter. So the meter will read whatever you probe with these leads. And when I was telling you that there's too much resistance in the air for electricity to go across a gap like this, if you had enough electricity it would go across, but it's really a lot. So with the normal electricity that we work with in the house or with the batteries or whatever is too low and it cannot do that. But when you touch them together, then you close the circuit. And if you see the way the meter's reacting, sorry the light's not better. See the way the red needle on the meter is reacting? It is showing you that electricity has flown through that circuit. See what I'm saying? Now as that needle moves like that in that gradual way, that's called a sweep. And only an analog meter can do that. A digital meter cannot do that. It'll show you a number and it may jump from 0 to 50 or 0 to 40, and then it could go in steps. It could go 0, 5, 10, 15, 20, but it cannot do an analog sweep like that, and you can't really see any smoothness of a wave. It's called a wave. So that's it, bud. I love you.